Hello guys, so have you ever wanted to create a magical effects on any kind of animal or creature? Then you came to the right place. This tutorial is going to be special because we are going to go into Blender. This has never been shown in any of my tutorials, so stay tuned and I hope that you enjoy it. Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We will have resources for every type of discipline. So hop in and have fun. Okay guys, so the first thing we want to do is to create a new object. Here we are going to plug in our monster, creature, animal, whatever we want. This might work for most of the scenarios, right? So as you can see here, I downloaded horse, right? This horse moves for as long as 32 frames. So what I did is to loop this. Once it reaches frame 32, I got this make loop from the labs tool. We can always go to Windows, sidefx labs, and install the latest labs tool development tool. And I also transformed this to make it smaller because the original was very big, and I blasted out the floor. So now we can see this is an error, but it's purely a visual. So I converted this into polygons. As you can see, these are polygons, and I added a trail to calculate the velocity. I also blurred a little bit the normals and time blended this. This is very useful in order to have substeps in any upcoming step of our simulations, right? So I did a time shift set to 1 because I want to have the still. This is the animation, this is the still, and we are going to work on top of the still one. So as many of us know, there is an attribute paint node, which basically, if we click on this option, we will be able to paint wherever we want. See? So if you paint, we can add stuff into an attribute. In this case, I decided that the name was going to be called tail. I did the same for the feet. So I selected the feet. Basically, I'm selecting everything that I want to make a distinction in the final simulation. I selected the back, and I also selected the life. The life is basically an attribute that I can control, where I'm going to have more, basically the particle is going to last more, right? And I also added an attribute noise set to multiply with these settings on the life. If I watch this closely, this is going to move. It moves based on time and a noise, which is very interesting. A really nice effect on the overall final simulation. I also multiplied life. As you can see, we have life right here by a value of my choosing. Then I calculated the velocity based on our normals. If we see closely, look closely, we have our normals, and if we set the velocity equals to our normals, we're going to have inside vectors. These vectors mean that the velocity is pushing outwards. And this is all I need for the time being. We have all of our attributes right here. We have life, we have feet, we have back, we have tail. These are the attributes I have. I can choose what fits me the most. Second step, we want to grab our painting attribute, which is basically here, which is also a still one, and we want in this case to blast our tail. Basically at tail is more than 0.1, so everything that is a tail is going to be blasted, because we're going to want to have more control over the tail later on. As always, it is good to have a blend node, and we're going to have out tail. Horse is going to have everything that we had before attribute wise, but without a tail. We're going to grab our animation right here. We're going to time shift everything and to point deform our still animation. So we're going to basically have everything we need right here. It's the same animation. We're going to have a time blend, and we're going to have this null, which is out tailless animation. In your case, For example, if you choose any other kind of animal, this method will help you delete some of the parts that you might want to have another method of sourcing, right? So what's the next step? Next step is to create our particle source for the pop simulation. So we're going to grab the out tailless. Remember, this was stopped, as you can see on the out tailless right here. It's not moving. And we're going to polyfill this up. We need to do this first because once we scatter, we're going to save these source prim and prim UV attributes. Let's see them. We have the source prim, basically it's the if we watch this closely, if there is a particle, for example, being scattered in this quadrant right here, it's going to store this number. It's like a reference. And we're also going to have a UV. So this means that if a particle is stored here, we're going to store this coordinate. We're going to store this coordinate on the polygon. This is called intrinsic UV. Could be, for example, .7 and this .3. So these are the two things we need to use to interpolate later on. On top of this, I decided to add another noise. If we see closely, we have a multiply set to 0.1 on live and this element size with an offset of $f or frame by 0.1. Basically, this is very hard to notice, but we have a slight change of gradient here, and as we can animated. This is going to be the body. So these particles are going to become the body. We group them with $os, so it's the same as the node. In this case, what we want to do is to grab the geometry tailless, to polyfill it again, of course, and basically start to choose where do we want to scatter. In this case, on the feet. And remember, always add these attributes. They will have a noise. The noise comes from this out tailless. As you can see, we have a noise. So this is translated into our scatter. We have the same for the back. And we group the feet and the back. Everything goes together. And basically, we're done here. Now, before merging this, I want to show this attribute interpolate. Remember that we have this out tailless animation. While this out tailless animation, if we polyfill this, as we did with the others, remember this set of triangles, we will be storing our primitive numbers and our UVs. So we can attribute interpolate the position based on these two values that are right here. This will return us an animation. It's like a pointer form, but better. Now, as you can see, we are missing the tail. So let's go here. Let's delete everything that's not that. Let's time shift this just in case, because we have a moving live attribute. And let's polyfill, let's ISO offset, and let's scatter a bunch of points. For example, 4,000. Let's transfer from our polyfill our values. And remember, play with this max sample count. If you have not so many, we're going to have a harsh edge. We're going to want to have a reference frame, in this case, frame number 1. These two have to be on frame 1. And the last one, which is going to be the animation, we're going to transfer every single attribute to the animation. Remember the animation right here? We didn't have any kind of attributes, so we're going to copy everything from the painted to. We're going to place everything that's not the tail to use a point deform to move the points inside the tail. Basically, this is what is going on, right? This is very, very cool. The tail on the first frame and the tail moving as referenced. Now, if we go here, we can do whatever you want. I decided to add a little bit of life to the particles, just a tiny bit. And I wanted to name this as tail, so this is out tail. We're going to merge everything together. As you can see, we have the velocities being transmitted from our sources, because our points are scattered with the original velocity that we had right here, if I believe, yeah, right here, be at n. But we're going to recompute these ones. So because I want to use a little bit of both of them, I'm going to do a trick, which is basically we can read this one just to start. And basically what I'm doing is to grab everything that's inside the group fit. That's why group fit equals 1. So I'm grabbing the fit and then saying, hey, velocity, you're going to be lerping. So if I have a vector there and I have a vector there, we're going to be lerping from one to the based on our velocity and the velocity of the other. So basically I'm saying this velocity will lerp to the other velocity. Point 1 at B, and ptnum is basically saying, hey, this velocity is going to lerp to this velocity. We're going to make like an interpolation bar set to 0 to 1. This is basically the blending. 0 is here, 1 is here, 0 is here, 1 is here. And we're going to multiply all these vectors by a constant because I don't want on the x-axis this to be so diagonally. I want to straight on the z axis. Otherwise, it will look something like this. These are the fits. They will look kind of messy once we simulate. So we have this, and as you can see, we are like controlling. Do I want the velocity or do I want the normals? Do I want the velocity? That's all I'm doing. And I did everything with every single group to have more control. So for example, the body, velocity, normals, velocity, normals. So I'm choosing whatever I want. I'm done blending and I'm saving this for like very cool indeed. Remember to always save your sources if they are slow. This is very slow. So let's save this. This should be set to $os, so the name of the node, and everything is going to work just as intended. Load from file, save to this, you are done here. So this is a small step, but we're basically projecting a little bit with some simulation. So I'm going to multiply this velocity by 2. Remember, all these velocity multiplications are done in order to improve my setup when it comes to how long this particle is going to live. So in this case, I'm choosing the tail one because I want the tail to be a little bit longer, and the feet I also want it to be a little bit longer in life. Then I'm going to do a pop network. The pop network is done like this, pop network, and I'm going to hop in. What I'm doing here is basically sourcing from all the points on my first geometry. This is the first geometry, the first input right here. And on the birth, well, this is overridden by my value, but I chose to have a 0.3 and a 0.2. I'm also doing a negative birth time with an interpolation set to negative and use point velocity. This will make all my particles emit a little bit smoother. On the pop force, I decided to have a wind going to the negative set. So it's going to go right there because I want to have like some sort of wind, or the horse move forward, so I want to fake the effect, and a little bit of amplitude will be nice. Also, nage is the linearized or normalized age value. So if you're going to live 10 years, right, what does 0 is to 10 and what does 10 is to 10? 10 to 10 is 1, so this will be a value set from 0 to 1. So the longer you live, the more effect you're going to have over this value. So this is going to be the amp of the noise, and it's going to be multiplied by this value, and the force the same, 0 by whatever number is here, and -2 multiplied by any value we have here. This is a nice trick. Remember to use expressions like we don't have to change anything here. We don't have to change anything here. The gravity is set to, instead of -9.8, it is set to 0.1. And I chose to have a ground plane. We can display this right here. And I also chose to have a static object. This is a deforming because remember the horse is moving. And I chose to have my out animation. The out animation, remember guys, is this one. So what is going to happen is that my particles are going to be emitted and also pushed by the horse. We can see this better once we delete all the attributes that we don't need. So everything but the h, the d, the life, and the velocity. This is what we want to have. And this is how it looks at the end. This looks very nice, very dense, but I decided to use basically a different simulation, which is less dense. You can choose whatever you need for this effect. So remember guys, we still have the group. The group can be used to, for example, using a split node. So we're going to split the feet, we're going to split the tail, we're going to split the body, and we're going to split basically the body. So let's go with the feet. The feet are basically, I'm grabbing the edge, which goes in this case from kind of 0 to 1, and I'm moving this to 0 to 14. The edge, in fact, in this case is not linear, so it's not really a 0 to 1, but I chose to use a 0 to 1. We can always use fit and decide arbitrarily which values we want. This is the same as a fit one, but we can move the values as we please. This won't make any difference, at least in this situation. But remember, you have the options to choose. So this is going to be a ramped edge. So let's see how this looks. This is how our ramped edge is going to look like. We have a value, which I chose to go from 0 to 14, and we have a ramp. This is not strictly how we should be using our ramps, because ramps usually go from 0 to 1, but in this particular case, it worked. And it worked, and it was useful for what I needed. Remember, usually you would want to have something like this, and then after the fact, you would want to multiply it by a value, in this case 14. This should be in fact the correct workflow. So we have this, right? Now that we have our values, we can interpolate, we can blend a little bit more, and we can use those ramped edge. In this case, if we are 0, so if we are just born, we're going to have full intensity, and if we are almost about to die, we are not going to have any intensity whatsoever. So we're going to choose our density to be the same as the ramp, the temperature the same as the ramp, the flame the same as the ramped edge, right? And the velocity is going to be multiplied by our ramped. We are going to rasterize this fellow, and we're going to do the following. We're going to make, this is my standard, so we're going to multiply our particle scale, right, like here, density scale, which is this one. Let me make this a little bit bigger. So we're going to multiply this one, right click, copy parameter, right here, and we're going to right click, copy parameter, multiply it by this one, and divide it by 4. This is going to make a relationship between the scale and the coverage scale. In this case, the particle scale, I chose this to be this value. You can choose whatever value you need, because the scales of your characters are going to be different, but basically try to have detail. Remember to use velocity blur and normalize by clamped coverage. And we need the flame, the temperature, and the velocity. In this case, because the feet are going to be fire. Otherwise, we would be also adding density. But in this case, I don't want to have density. Always a timeline. And for the next one, we also have the same. This is the same idea. We're going to have a ramp on the tail. We're going to add, in this case, a noise, because I want this to be more interesting, just a tiny bit. A multiplication, just a tiny bit, and this can make this a little bit interesting. And the same idea of everything, every single material. In this case is, well, basically the same. This is a copy paste of the other one, and a timeline. The same goes for the back, exactly the same methodology, exactly the same, nothing is different here. And timeline. The last thing is the body. I want this to become not a smoke, so only density. So I decided to just have, well, I have everything here, but when it comes to the rasterized volume, I only choose the density and the velocity. Everything else is exactly the same. And it looks like something like this. So you could choose here to save these guys as a file cache, the same as we did with the particles, but I didn't feel the need to in this situation. So we're going to grab the tail as animation, I'm going to polyfill it, and we're going to BDB from polygons. So basically, if we fill the interior and we choose to add 1 on this one and set this to point B, we can choose this from here and set the velocity name to B or displacement, velocity, and acceleration, and name the collision to collision. And you're going to have a collision source, which is going to be very useful for any type of volume simulation, for like Pyro, like flips, etc. This is going to be our collision source. We don't need anything else. Look at this, we don't have the tail because we're going to be sourcing from inside the tail. And we're also going to grab a camera. Remember, I have this camera. I don't know if we can see. No, we can't. Well, the camera is here. I chose to make a camera. And if we name this sync, we go to from camera and grab our camera. We can make some values like, for example, the far, right? This is going to determine how far this camera goes. And we can increase by -1 and also by 0.1 here. So this is going to make the frustum a little bit bigger. You will see why. We will convert this into just a BDB. This is also going to be converted as a BDB. As you can see, this one is bigger than this one. So if we subtract, we're going to create a hole inside our shape. This is also the same size, 20. So we're going to have like a set of walls. This is going to be useful to delete volume inside our simulation. So let's hop into the simulation. So let's go with one thing at a time. Let's use our fit source. And let's not use any microsolvers. Let's not use anything. Let's not use a sync, and let's not use the ground. And we will also be setting this to a bigger value so we can see this a little bit faster, perhaps by 8. So we have this voxel size right here. Also, we're going to set the substeps to 1. This is going to be very fast. So once you go hop in, you need to create your Pyrosolver Sparse, your smokes object Sparse. You're going to plug this together, and in this case I'm going to close below, right? Because we don't want the smoke to go below the ground, of course. On the visualization, we're going to use multi-fill, and we're going to set this to an emission, set to 1, temperature, and smoke only density. That's all it. We don't need anything else. So first of all, before we set anything here, we have a couple of noises. We need to go to and make our first source. So let's do a volume source, and let's set this to sync and then to source. And we can choose anything. In this case, I chose this outfit volume source, which is basically this one, the first one, right here. So I chose that one. Remember, I have flame, I have temperature, and I have velocity. We have the 3 same things right here. Remember to click here, otherwise you might have an issue while simulating. And let's see how this looks. This is how it looks. This is, remember, very low res. We have the velocity of the feet moving forwards. We have some dissipation, which is here. We have some cooling, which is the fire cooling down. And we don't have any gravity accelerations because I don't want to have a gravity acceleration. And on advanced, the version is set to BFECC and clamp. Remember, this is very useful and important for you to have. On the resizing, I lower the padding to 0.04. This will make our simulation more optimal. That's how it is. There is nothing else. So let's see this with a little bit more resolution. Oops. So let's, instead of 0.8, let's use 0.4. Now we're going to have more resolution. This looks already very nice. And let's start to use our collision. Our collision is basically what we did with the horse. It's the BDB. We can see this right on the visualization here, collision. This is the horse moving. We also have the velocity. Remember, this is going to be set to out collision. We're going to plug in the horse. We are not going to enlarge the fields, and we're going to basically look that we had the velocity correct and the collision correct. That's how it works on its own. As you can see, there is nothing on the inside of the foot, and the foot or the body is dragging the smoke around. That's the collision. A wind. I want to also have a little bit of wind going there to the negative z axis. So now everything's going to go on the negative side, right? We can see this a little bit here. And we also want to have a little bit of disturbance based on the block size, in this case 0.2, this is on meters, 0.2 or 20 centimeters. I decided to have more strength, a little bit more of threshold. This will change the overall look. You can play around with this. Don't be afraid of choosing new numbers here. And on the control, I chose temperature from 0 to 1. The more temperature, the more disturbance. So let's see how this looks. As you can see, we are going to have a little bit more of distraction on the overall simulation. The same for the turbulence, 0.2 on the scale or 20 centimeters, sorry, 0.3 on the size and 0.2 on the scale, on the amplitude. And on control size, temperature, and we set this to 1, so everything going to be controlled at the temperature. And we have a different one with different radius, everything is different, just a tiny bit. And I forgot to plug this in, so let's see this again. Basically the wind is going to move everything to the right. Disturbance is going to disturb everything a little bit, as you can notice. The turbulence, the both of them are going to disturb everything, or to move like a turbulence, only where it's hot. And this is our thing. This is kind of confusing, but watch this. The sink is basically programming our sink, and we're targeting our density. So the smoke we're targeting, and everywhere where we are having density, we're going to subtract by 10. So we're going to be deleting density. And this is important. Remember not to use enlarge because you are going to make a mess. This is important. I don't know if we're going to be able to see it. I really don't know. But once it reaches a certain threshold, which is the camera, everything is going to stop. Okay, so let's add the body and let's see what happens. Now we have the body. We can also start to add the back and the tail. Look at this. We have some same things, like for example, the velocity on the tail is a little bit slower because, well, yeah, at one it was too big of a movement. And I did something similar for the back. It's at 2.3, and the feet is, the temperature is a little bit higher than usual. So let's see how this looks. I think it looks amazing. As you can see, we have some kind of stepping, and this can be fixed with adding a little bit of substeps. And if we increase the resolution, once we import this, once we convert this to BDB, once we vector merge every single velocity, as you can see here, velocity is divided, velocity is merged, and then after we write the velocity to 16-bit, only then we're going to save this as a BDB, like we have here. This is very intense for the PC. Then, and only then, we're going to be able to visualize, for example, on the Pyro bake volume. If we add some lights, as I did, we can start messing around with these values. On the smoke, I decided to use, well, a ramp with a little bit of color. I used the fire on 13. Remember, we can always compute these values again and mess around with the gradient. Remember, we're not going to be rendering this here, so it doesn't really matter. And that's how it is. Remember, the intensity volumes, change it to flame because we're using flame to visualize. And that's how it is. We can also do it with a visualize node, visualize smoke node, but in this case I chose to use the Pyro bake only for pre-visualization. So I decided to split the velocity. Now I'm looking at the velocity. If we choose to resample this to a different voxel size, we're going to have less voxels. In this case, 200,000 versus 19 million. It is a lot of difference. So let's save this because we're going to use it for the next step. We saved it and we hide it, but it's still here. Remember, this is only a visibility node. It doesn't really matter, but it's easier for the viewport. Okay, so we're almost about to finish with the horse simulation. So if you reach here, I congratulate you. We're almost done here. So let's grab our tail. Remember, this is the tails. Right here, this is the tail. And let's grab our paint base. Basically, these are the attributes, so we can visualize, for example, the life, the feet, the back, also the tail, but the tail is not here, obviously. And we're going to scatter. In this case, the tail are already points. So I decided to add this function. So each frame is going to change the random, and this is going to be based on pitnum also. So if the random of these two values is over the threshold, which is a really low threshold, as you can see here, we're going to delete everything. So if this goes from 0 to 1, and well, we have a high probability that this is really going to be higher, we're going to delete this. I did the same here with a different threshold, and here with a different threshold. I also decided, well, nothing is going on here, nothing is going on here, and I decided to add a group. The group are being called point. These are not going to be trails, but sparks, let's call them, little points flying. So let's merge all this together and let's see how this looks. This is going to be the tail particle source. We have the velocities, we have everything. Well, we don't have, yeah, we have velocities, but we are not, there we go. Now we can see them, how the velocities working. Let's grab the paint of the whole body and let's choose to scatter where on the feet, but only 4 points. And let's global seed move this. So these are 4, these are 14, and these are also 14. Yeah, as you can see, different seeds. Nothing is going on here, and nothing is going on here, and we set the same points. It's going to be the points, which will be flying around. This is going to be the feet source, and we're going to do exactly the same for the back. Exactly the same, nothing is changing. So we're going to merge these two. And the tailless animation, in this case, is going to be merged right here. So we're going to move our particles. So we have the tailless animation, and we're moving the points based on our animation right here. Okay, so now that we have this, we're going to merge the tail and the every single point, and these are going to be our sources. Remember, it is always nice to save this again. So I'm going to save this just to show you this is faster. Every single second we are saving here is another second we are winning on the simulation. So I chose to have way more life here, so my particles live a lot longer. And let's hop in. Remember, this is the particle, the pop solver. This is the same source set to all points. Use first context. This is set to the basically the same with a different point variance. Nothing else. Only on the points, so everywhere where I have points, so not the trails, I'm going to have a slight drag. So I want the small particles to move slower than the free particles or the trails. This is going to be affected by the velocity we made just before, right here. No, wait, right here. And that's why we resample this, so it's faster. And I decided to use a velocity of 30. So everywhere where there are no points, this is going to be affected by this. And in this case, I chose everywhere where there are points to be affected, but I turned it off because it looked nicer. We can always turn it back on or off. So the force, this is the wind that we had on every other simulations, and I chose to invert basically the force. So if we are just born, we are using a value of 1. If we are dying, we are not going to be no longer moved to that position. So we're going to be reduced. So that's pretty much it. The gravity is 0.1, and if we simulate, this is what we are going to achieve, which is pretty cool, right? If we see from the camera, this is what's happening. So let's split this between the points and between the free particles. The points are going to have a trail, and they're going to be added right here based on the ID, group ID. Click here and ID. And we're going to make this look a little bit different. Let's hop in. Basically what I'm doing here is to grab the notch, and I'm fitting the notch from 0 to 1 to 0 to 1, just in case I want to have, like, I don't know, a 2 or a 3. This is only a visualization, right? And I'm going to ramp the colors. These are the colors. So basically these values here. I'm also going to multiply this by the length of the velocity. So if it's faster, this is going to be multiplied, right? So it's going to have like a difference of colors. and this is going to go straight to CD. And here on the multiplication of the edge, so the velocity is going to go to the edge, and this is going to be a spline, and it's going to be called width. So the older you are as a particle, the thinner you're going to become. This is how I control the shape. Let's go, I divide inwards, and let's go to the polymer section. You can see we do have some particles here. They're very small, so I'm going to increase this 10 times. So as you can see, we are moving the width of these particles by this ramp, which is very cool. So I want to go back into the value we had, because this is going to be very visible in render time, and we're going to use also an alpha. This is only for visualization. We don't actually need the alpha, but basically I'm clapping the length of the CD to 0 and 1. So if it's 0 or below, it's going to be 0. If it's over 1, it's going to just be 1. I'm resampling this so we have more points. I'm doing a point deform right here. I'm using the edge, so the life is going to determine how much noise you're going to have. This is going to be the ramp, which is this one. And we're going to multiply this by constant, and we're going to plug this into the amplitude. This is going to be a simple add plus a noise. So if we move this a little bit, the noise is going to change. If we add more amplitude, this is going to be displaced even more. So basically I'm deciding, hey, if you are born, don't displace, otherwise displace. See? So I'm masking where I want to have the displacement. The polywire, well, we already saw this, and the normal just to make this pretty to our eyes. So we cannot see anything, but they are there. You can see they are right here. So here are the points. The points are exactly the same in every functionality. We don't have a trail, and we have an alpha, the same one, and we have a sphere. And basically saying, hey, this is the size. Remember, we had the p-scale. Well, before we had the width, now we have the p-scale. I forgot to tell you, we're applying the width divided by 4. So this value right here, which is the width, is going to go straight into here, but it's going to be divided by 4. So the p-scale, we can take a look right here. If we want, we can make these spheres bigger, and we can choose the variation right here. So if we want more bigger particles, we will. So we cannot see much here, but they are over there right here. They're very, very, very hard to see. So if we merge everything, we should be able to see our particles and our lines. Sorry, this is very small, but it's what we need in order to render this. And take a look, this is how to export all your geometry to Blender. First of all, delete everything you don't need, but. So I need edge, I need life, and I need a velocity. And this create based on our edge. Do not write the values, but make a color. Blender likes color attributes. That's the only thing that Blender likes. So remember that. The same with the life, and well, forget about this one. And basically what I'm doing here is to set the edge everywhere the same. So if we can see closely, once I make the attribute, we're only going to have edge on the X or on the R or on the first array input. So I'm basically copying everything the same. Life X is going to be everywhere the same. And I'm going to export this as Owawa. This is the name file, and that's about it. We have everything we need. Okay, so we are in Blender. First of all, let's change this to cycles, experimental, and you can change to GPU. I'm going to stay in CPU because I'm recording. I'm going to go to performance. You don't have to do this, and I'm going to change this to 44 threads. One more thing is go to life path and set this to 4, and that's about it. So we are going to delete this cube, we are going to add a plane, and we're going to scale this by 10. Also, what we want to do is to file import alembic. Let's go to our file, Firehorse, and we're going to save this location. Right, so Shift C. So let's go into cache, let's go to Sparse, and let's load this up. We are going to have some sparks right here, as we can see, they're right here. And we're going to also Shift A, and let's load in a volume, import BDB volume. Let's paste this section. Let's go to cache. Let's go to smoke swim main, and let's go here and drag everything we have. We want to select everything, and let's check this detect sequences. So let's go again into frame 93 or 90, and we will have our beautiful horse moving. So let's go into shading. Let's divide this window in half. Let's go into renderer here. Let's go inside the camera. Let's open these two guys. Let's go to view. Let's go to camera lock, and let's move this fellow around. Let's zoom in. We don't need this. This doesn't matter. There we go. So now we don't want to move the camera. We want to only zoom in, so we have a better view. There we go. Let's stay like this. So another thing we want to do is to remove this light and remove this background color. We want to make a new light, so let's make 3 lights. In fact, one is going to be a point, which is going to be on the chest. Somewhere around here should be fine. A little bit lower, and let's set this light color to some kind of a dark orange, and let's set this to 20 or 30. It's okay. Let's make another light. This one is going to be a spot, and we're going to move this around somewhere around here. There we go. This is what we want to achieve. We can move this around here, point this towards our horse. There we go. So with this spot we want to increase the power. Let's change the color to some kind of a bluish tone. Let's increase the area, let's increase the blend, and the radius, make it bigger so it's softer. Let's make this bigger, and let's copy and paste this guy, and we're going to move it just under the horse face. I'm going to rotate this somewhere around here. We want to use this option, and let's face it to the head of the horse. There we go. This should be it. So this is fine. Let's a little bit better. And with this light we're going to do the opposite. Let's reduce the radius. Oh, sorry. Let's select this light and let's reduce the radius. Remember, the head of the horse should be inside. The blend is going to be reduced too, and the radius is going to also be reduced, so it's sharper, and we're going to increase this a little bit. We can move this somewhere our liking. This should be fine. Okay, so for the ground we're going to go to bridge. I'm going to leave a link in the description so you can check how to do this, and we're going to export this guy. This is successful. So while we select this, we're going to select our Iceland sharp rock material. Let's move the emission to our normal, and let's select the scale to 0.02. Let's use this camera just for a bit. Let's go to the side, to the other side, and see our ground, and let's move this just so it starts to clip the feet of the horse. There we go. So let's go again into our camera, and let's hop into the material of the horse. So let's make a new one. Let's delete the density, let's delete the temperature, and we're going to do everything from scratch. So let's select an attribute. This will be called density, and let's plug this into our density. Let's do a range, map range, and we can do whatever we want here. We can multiply, for example, twice the density or not. And let's do an attribute copy. So let's copy these two guys. Let's use a flame. Let's also use a temperature, and let's multiply these guys, this one with this one. This has to be on multiply, and if we go into the emission strength, we will have something like this once I change the color. There we go. And we want to have a curve RGB ramp, so two, one next to the other. This won't change anything. It's going to go into the color, and let's do a color ramp so we can use the colors we want. And let's also use a map range and a map node set to multiply. This should be set right here, and this should be set right there on. This will be set to 125. This will be set to 5. And we're going to create some kind of a gradient so we can have more contrast in the middle. This is going to be contrasting everything, and we're going to set this to 140 perhaps. So we have the same. So now we can choose where we want to have our fire, as you can see. With Ctrl V, we're going to select this part of the render, and we're going to colorize this with some colors we want to create. So for example, this green and bluish tone would be amazing. So as you can see, perhaps we want to have more in the multiply. Vicinity should be fine, bigger. Ctrl V and select more. It's just a matter of deciding what colors we want to have. Perhaps we want to have a reddish or more bluish tone. Increase this. There we go. Now we have two colors, and we can play around a little bit better with, for example, I don't know, a yellow and green. Let's make these values bigger. So we move this just a tiny bit. We will achieve this kind of effect, which we'll be able to see better with different colors. This is part of the creative decision. So let's have something like this. Okay, this is very fine, and we need to change because we have the material on the ground. What we want to do is to actually have displacement. So let's use a subdivide surface set to simple adaptive, and this will be set to 8. And on our scales, let's go and set, for example, 0.2, 0.2, and 0.2. So we are almost done. I'm going to make these lights a little bit better. Some more power here so we can see the head a little bit better. This should be fine. Let's hide this here. Ctrl V, let's only look at the face. So if we move this a little bit higher, there we go. More to the face. And what we want to do is to change the anisotropic to 0.2. And the color can be set like a brownish tint. Ctrl V, and we have our horse shaded. And we're going to do something similar after we change this to a more orange tone. There we go. To our particles. So let's select the particles and let's make a new material. In this case, we're going to use the attributes again. This is going to be set to life. This is going to be to age. And we're going to, for the time being, only watch these guys. They are going to be divided. So math divide. Let's select one and the other. Let's go to emission strength and set this to white so we can see this better. It's going to make a ramp from 1 to 0. And as you know, we can always use a color ramp like so in the strength, and this one to the emission. And the color can be set, for example, to a violet. And we're going to do one final math where we're going to do a multiply, and we're going to select the value of our choosing. 8, for example, is okay. So let's visualize everything together, and let's just wait for a moment. As you can see, this is slowly taking shape. So I'm going to load that file, which is exactly the same, but it has a little bit more development when it comes to the colors. So let's go to render and let's press play. You might hear my voice a little bit choppy because this is more intense. I have all the cores, but let's wait and let's see how it looks. So as you can see, this instantly has a lot of detail. This is the same shader, the same technique, but different colors and different camera, and a little bit more time when it comes to shading. Hello guys, if you enjoyed the tutorial, please leave a comment and join in my Discord channel where we are always talking about FX. See ya!